Alright, so here's part 2. We're going to look at a couple more examples here. This is looking at the second application of our theorem, which again, in case you did not watch the first part of the video and you're just trying to get ahead, we're looking specifically down here. When two lines intersect outside of a circle, you take half the difference of the intercepted arcs. So half the difference of the intercepted arcs. And that's the equation we're following there. So, how do we do it in this case? Well, there's a couple things we want to do. So, in this case, it doesn't tell you what you're solving for. So, let's say this here we're solving for x. Okay? It's solving for that arc right there. Well, again, the angle that is formed by the lines that intersect outside the circle at that point, that angle is 70 degrees. Well, it's just half of the difference, right? Half of the difference of the big arc, which in this case would be x, right? It's the big arc, x, minus the small arc is 110, right? The big arc minus the small arc, which is 110. Now what do we do? Again, you can distribute the 1/2 if you'd like. I think there's really no point to do that. You might as well just multiply both sides by 2, which would cancel out on the right side. You get 140 equals x minus 110. Add 110 to both sides and you get x equals 250. Now hopefully some of you notice that you really don't even have to apply the theorem in this case, because we have a circle here. It gives you one of the arcs is 110, and there's another arc that completes the circle. Well, the two arcs that make a circle are going to add up to 360, right? So it would make sense that we got 250 because 250 plus 110 is 360. So really, in this case, you don't even have to use the theorem. You can just use logic, which is just as appropriate. You don't have, unless it says you must use theorem 12-1 or 12-11 or whatever book you're using, it doesn't matter. Logic says this arc here has to be 250 because the rest of the circle is 110 and they add up to 360 anyway. Okay, so there's multiple ways to do these problems. Sometimes the theorem applies, only the theorem applies, and sometimes there's 6 ways of doing it. So as long as you know one of the 6 ways, who cares? Alright, next problem's a little bit trickier. Excuse me, not too bad. If we know that this arc here is 90 degrees, and we're trying to solve for this angle here, angle x. Well, again, we know that x is half the difference of the big arc, but do we know what the big arc is? We don't. This is the big one minus the small one, right? Well, the small one is 90, because that's the one it intercepts, but we don't know what the big one is. So we have to use logic, same logic that we used in this part here, right? Same logic there. This is 90, and this is 110. Well, that adds up to what? 200 degrees, which means the rest of it, to complete the 360, has to be 160, because those 3 arcs make a full circle, so the big arc is actually 160 degrees. So again, the logic comes into play here, where sometimes you have to find other things to figure out how to apply this theorem. So again, we can just simplify in the parentheses here. You get x equals half of 70, right, which is 35 degrees. Okay, x is 35 degrees. Now, I must point out here, sometimes, again, we have a tangent line here, right? We have a tangent line here. A common mistake is for students to say, oh, a tangent line meets the radius at 90 degrees. Well, we don't know this is a radius because the center of the circle could be here, which means this line here, or this segment, would not be the radius. So you cannot assume that this is a 90-degree angle. You can't. Even though it's tangent, I understand it's tangent, but you need to know that it comes from the center. If it came from the center, then yes, you could say, oh, it's a 90-degree angle, and you could do other things. But just FYI, that's a common mistake that I've seen multiple times. If they don't tell you where the center is, you can't assume that it's right there. Okay? You cannot do that. Alright, 2 more problems, and then I swear I'll let you enjoy the rest of your day. These problems are kind of tricky, though. So let's figure out how to do this. Let's do number 3 first. This is dealing with segments that intersect outside of a circle. right? Outside of a circle. So we know, let's just go for x right away. We know, and this is problem 3. Oopsies. We know that this angle here, which is 50 degrees, is half the difference, again, because it's outside, right? It's half the difference of the big arc. Well, what's the big arc? 160. What's the small arc? It's x, so we don't know what that is, so we need to solve there. Multiply both sides by 2. Oh, I multiplied the same side by 2. That's not good. So we get 100 equals, these cancel, 160 minus x. Then we need to do what? Well, if we subtract 160 from both sides, we get negative 60 equals negative x. Don't forget that negative, or else you're going to get negative 60 equals x, which hopefully would confuse you because that's not logical. And as a geometry student, you're using logic, right? So please never give me a negative angle. That will just put a sad face on your problem, and that would not be fun for anyone involved. So divide both sides by negative 1 or multiply both sides by negative 1, you get, oh, that's a circle. You get x equals 60 degrees. Now, if we want to find y, right, we want to find y. Well, y is occurring, let me clean up this picture here so we can kind of get a fresh look at it. Y is this entire angle from line to line right there. Okay, so we need to think of the, we have a tangent line, so there's two ways of thinking about it. Either you remember the theorem from last section, which says that the angle formed by a tangent and a chord or a secant, potato, potato, chord, secant. So an angle formed by a tangent and a secant is half of the arc that it creates, right? So we can say that y, let's call this arc A. We could say that y equals half of A, okay? Or if you want to apply this theorem, well, it doesn't intercept outside of the arcs, or I mean outside the circle or inside the circle necessarily, but you could say that y is half. Let's say we were like, okay, just pick one, pick outside. Well, the big arc, again, is A, minus the small arc that it creates. Well, there isn't a small arc, so you get A minus 0. So the theorem kind of applies here, but this is kind of where it's just easier to remember your old theorems. Old information is always good. So how do we figure out A? Well, again, you're going to use this logic as much as possible. If that arc is 160, and we know that x is 60, that leaves us with 220 degrees being occupied, right? So the rest of it, arc A, would have to be 360 minus 220, which is 360 minus 220, which is 140, right? So y is half of 140, which is 70 degrees. Now, I just realized, obviously you heard the bell ring and I wasn't keeping track of time because I was so excited about this material. I want you to try, I use a star and there's a star, that's funny. I want you to try number 6 on your own. We'll talk about it in class tomorrow. So the only thing that's different about this, all these lines intersect inside the circle, which means now instead of subtracting you are adding. So that's the hint I'm going to give you. Try that on your own. I might put it on your quiz tomorrow, but we'll talk about it in class regardless. All right, thanks guys. Have a good one.